Okay, with our part drawn, we're going to go to milling stock and right click on it, then go to mill 2-axis, and all of the machining operations we're going to use are going to be either pocketing or profiling. Now we're going to start off with pocketing. Go click next, and this takes us into our wizard, which is where you're going to do 90% of your toolpathing in a wizard. Actually, you're going to do a lot more than that. Almost all of your toolpathing using BobCAD is going to be using the wizards because they're really cool and do a lot of the work for you. First, we click on Select Geometry, and I'm going to do all 4 of these bolt holes. So clicking all of those, hit the space bar or click OK. You get a quick sketch just showing you what you've selected, so you've kind of got an indication of whether that's what you wanted or not. If it's good, click Next. Rapid plane. This is what I was talking about in the last video when I mentioned that I was going to have some bolt heads sticking up out of this thing. In this particular operation, since I'm cutting the holes that the bolts will go into, or the screws will go into, I don't have to worry about it, and I can keep a rapid plane of just 1/10 of an inch above the surface of the stock. Top of part is at 0. That's pretty much standard practice with the router. That's what I do anyway. Everyone's habits are different. A lot of times you'll hear me saying, well, this is standard practice. It's not standard practice except for me. Maybe everybody does it that way. Quite likely I'm doing it all wrong, but everybody's shop is a little different, so take it all with a grain of salt. I'll click Next. I've come to some posting parameters. Work offsets is pretty advanced stuff. You're rarely going to be using a work offset, especially at first with a home-built CNC router. Rotary angle, we're not doing 4th axis work here, so nothing to enter there. I'll click Next. And now we get to what tool am I going to use. It defaults to just whatever it defaults to, in this case a 1/2 inch end mill. Since I'm cutting 5/16 holes, that's obviously not what I want, so I'm going to click on Tool Library. And in here I've got some tools that I've defined in addition to the ones that just came stock with the program. I'm going to be using a 1/8 inch single flute flat end mill. I click on that one, click OK, and here it is set up. The feeds and speeds, I generally input them manually. Again, everybody's different. A lot of people like to have everything set up just so, but I never know what I'm going to stick in front of the router, so I just tend to set up each operation individually for whatever I've got there. In this case, we'll go with 36 inches per minute, which will work pretty well. And the plunge rate that fast too. So we go on. I want to use a toolpath called Offset Pocket Out. Basically, the tool will start in the center of the hole and it will describe a small circle, and it will move out toward the edge of the hole and describe a bigger circle, and that will be the name of the game. Going to use climb milling and no side allowance. The reason being that the 1/8 end mill that I have only has flutes 1/2 an inch long, and this is 3/4 of an inch thick stock, so I really can't do a good finish pass on this. So I'm just going to go with no finish pass and cut the thing to shape in the first run. Going to go with multiple steps. The total depth is going to be 3/4 of an inch, so 0.75. Even depth is set, and we'll go with 1/8 of an inch, 0.125, and that'll give me 6 actual levels of cut down these holes. Because it's such a small end mill, it's just not going to do well if I try to go much deeper than that, so we'll go with that. Go to Next. Plunge entry, so it's just going to poke its way down in there. That's no problem. It's an end cutting mill. So the sorting, I generally just let BobCAD decide which hole it wants to cut first and which it wants to cut last. Unless I've got some really specific need for a set order, I just let the software default to whatever it wants to. Alright, because I said that I'm not going to do a finished tool pass, I'm going to specifically tell BobCAD that by setting a tool diameter of 0. When you do that, BobCAD says, oh, okay, nothing to do here. You can then click Finish because you're done. So we're up here with our feature Pocket. You can click on Geometry, click Reselect, and it will generally have this stuff already selected. Sometimes you'll have to actually re-click something, but generally you're going to see the geometry that you've got this operation set up for. Hit the space bar or click OK, and then go to Pocket, right click there and tell it to compute the toolpath. And now you'll notice I'm going to go ahead and blank the stock so that you can see these better, just because I've got a bad color match there and they're difficult to see. So as I said, the tool is going to come down near the center. It's going to describe a small circle. It's going to come out toward the edge of the hole. It's going to cut a bigger circle such that it's going to leave a 5/16 diameter hole here. Then it's going to go down another 1/8 of an inch, and it's going to repeat that procedure. It's going to go down another 1/8 and repeat that procedure. It's going to go all the way down to 3/4 of an inch deep. Then it's going to move on and repeat that process there, there, and there. And that all looks pretty good. There are no crazy toolpaths going someplace bizarre. So we'll just clear that. I'm going to go back to, actually I'm just going to leave the stock off. I know the stock is there, and it's just going to get in the way of seeing all the various toolpaths. Alright, I'm going to go ahead and set up for my next one, which is going to be cutting this 3/4 inch hole clear through the wood. So I go back to Mill 2 axis, and go into Pocketing again. Click Next. Select the geometry. I want that circle. Hit the space bar, click OK to confirm the selection. Click Next. Alright, in this case, when this toolpath goes into operation, there are going to be a couple of screw heads sticking up above the surface of the wood. Probably no more than around 3/16 or so, but I want to be sure to give them plenty of room. So I'm going to give myself 0.3 inches above the surface of the stock for my rapid planes. I'm going to put that in every toolpath from here to the end of the machining process, so that any move it makes, even though in this case there are no rapids, it's going straight down, it's going to cut this, it's going to come straight back out. But I really want it set in my mind that I am not going to come near the surface of that wood because there are screw holes in there. So I'm going to go ahead and put that into every operation henceforth. Alright, top of part is still at 0. I'm not going to do a chamfer, so I click Next. I'm not using any rotary axis on this. Click Next. Alright, here once again it's defaulted to a tool that I don't want, so I click on my tool library and pick the tool that I do want. In this case, a 1/4 inch single flute end mill. Click OK. Set up the speeds and feeds that I want. In this case, we'll go 36 inch per minute and give it the same in the plunge rate. Not going very far in these because you're going in two axes simultaneously. You're probably never going to get out of acceleration phase in them. You could set that very high if you wanted to, and in my machine at least, my acceleration is set low enough that, you know, if I set it to 72 inches per minute, it would never get that fast, just simply because it's such a small distance it would never get out of acceleration. Alright, so I've got the speeds and feeds set up. Click Next. I want an offset pocket out, just like these, so it'll start in the center, work its way out, go to a deeper level, start at the center, work its way out. I'll set for climb mill, 50% cut width. Those are the defaults. In this case, I do want a finishing pass. This is a 1/4 inch end mill. It's got an inch of flutes, so it's going to be able to do a full finishing tool pass around here. And I will set up for that. So I'm going to leave 5/100, roughly a 1/16 of wood around the inside of this, and do a single pass to finish that up. So I've got that set up for a side allowance. We'll go with multiple steps. I would go 3/4 of an inch in depth. I want to go a little bit less. No, I can go a 1/4 inch. Um, there's a school of thought that says take lots of light passes, and a school of thought that says dig that sucker in deep and take as much as you can take. Uh, if you only take very thin passes, you generally only get wear on the tip of your tool, and that's kind of wasting a lot of the tool to do that. So the deeper you can go, the deeper you should go, says another school of thought, just to be getting the most out of your tool and not just dulling the very bottom part of it. Um, More often than not, what I've heard is the diameter of the bit is a good depth of cut for just general use. Um, don't know whether deeper would be better or worse in this case, but I know I can do a 1/4 inch, so I'm going to. That'll make that 3 cuts to get through the entire part. I've got my allowances up, I've got my depths up, I've got the number of cuts that I want. So click next. Plunge entry, just as before, I'm just going to go straight down toward the center, do a small circle, do a bigger circle. Alright, in this case, I am going to do a finish cut, so I set up for that same tool, which is 1/4 inch end mill. Tell it OK. And set my feeds and speeds, which 32 is fine. 32 plunge rate, just because I hate to sit there and watch the mill very slowly go in and out of holes. It's just moving in air in that case. Alright, standard compensation, and the plunge there, so I'll finish that one up. And once again, I'll click on geometry, reselect. Yes, that's correct. So I either hit the space bar or click OK to confirm it. Go to Pocket and compute toolpath. Now this time it's a little bit different than the bolt holes. You'll see it's going down 3 different levels with in the center, small circle, move out, bigger circle, then down and repeat. Once it's done all those though, and it's cut almost 3/4 inch diameter hole all the way through the part, it bumps over and it goes to 3/4 of an inch exactly, and then it mills using the side of the tool the entire hole, about a 1/16 of an inch of wood off of there. And this is for precision. When you're going in and doing roughing, you're putting big side forces on the side of the end mill. You're making the whole machine work hard, and these are not conditions that are conducive to precision. Whereas when you've got a hole that's just got a little fuzz of wood to take off on the inside, you're not pushing very hard on the end mill. You're not causing all kinds of stresses on the machine. The machine's just pretty much idling along, doing nicely, and you get more precision that way. That's what finishing passes are all about. Part of it's about appearance, but a lot of it is just about precision. You get much nicer cuts when you're not shoving big side loads onto your end mills. Okay, so that one is okay. Now we're going to do a 3/8 of an inch deep pocket on this larger circle. So I'm going to once again go to milling stock, mill 2 axis, pocketing. Go next. Select my geometry again. Click on that one. Hit the space bar or OK. Go to next. Again, I want my rapid planes higher because now I've got bolts sticking out of the top of the piece. Go to next. I don't want any rotary axis action because I'm not using a rotary axis. My tool library, I want a 1/4 inch single flute end mill. Click OK. Feeds and speeds. 36 inches per minute. 36 in the plunge. And this varies on every machine. Some machines will go much faster. You always want to be going as fast as you can go with a router, consistent with accuracy and the chip load on your end mill. Generally, the faster you can go, the better for the life of your tool. But some machines are faster than others, and you've also got acceleration to deal with. As I said a minute ago, and the size of these holes, I'm not even sure I will get to 36 inches per minute, but I'm putting that as a value anyway. Offset pocket out, climb milling, a cut width of half the diameter of the tool. Alright, in this case, once again, I am going to have a finishing pass, so I'll leave roughly a 1/16 in there, 5/100ths. I'll go with multiple steps. I'm going 3/8 of an inch deep with this. 0.375. So half of that, 0.1875, that gives me 2 cuts. I can live with that. For the next, plunge entry is fine. For our finishing pass, same tool, 1/4 inch single flute end mill. Okay. Finishing passes generally want to go a little bit slower. 32 is fine on this. That's not very fast, even though it is in a small circle. I'll put the same for the plunge rate. Compensation, I don't have to worry about anything there. Plunge entry, vertical leads in, same as the lead out, that's good. I finish up, right click on geometry and reselect to make sure that I've got the correct geometry to feed the toolpath. I do, so I hit the space bar, click OK to confirm the selection. Right click on the pocket and tell it to compute the toolpath. Once again, it's getting a little cluttered, but you can see it's doing exactly the same thing. It's just not going down as far. It's only going down 3/8 of an inch here, whereas it went 3/4 of an inch here. Alright, there's only one operation left to do, and that is the profile, which will cut out the whole part. So we'll go to milling stock, mill to axis, profiling, which is the first thing, that's what was already checked. Tell it next. Takes me to the geometry selection page, so I'll hit select geometry. Instead of just clicking on every single one of the 8 pieces that make up this piece of geometry, I hold down the shift key and click on any part of it, and it selects everything that's contiguous and joined. It will basically, it'll always pick up everything. Haven't had to do that with these circles because they are already shown up as one single entity to BobCAD. But the rectangle and any larger part, any oddball toolpath like that, it's also a really good way to make sure stuff is joined. If you think it is, but you hold down shift and click on it and it doesn't select everything, that means that arc and that line aren't selected, if that's where the selection ends. Or they aren't connected, I should say. Alright, so I've got my geometry, hit the space bar, click OK. There's my rectangle, I click next. Again, my rapid plane I want a little higher than the default because I've got the screw head sticking up out of the top of the thing. Top of part is at 0. I don't have any rotary axis to deal with. I will use arc moves. Once again, on tool library, I don't want the default. I want my single flute 1/4 inch end mill that I'm doing all of these operations except the bolt holes with. Click OK. In this case, I've got 6-inch runs here, so I can get up some speed, and I want to make use of that. Anytime you can go faster with a CNC machine, you want to, because you're going to spend an awful lot of time watching this machine put along very slowly. So we'll set up 48 inches per minute. I can probably get that going that fast over 6 inches, and well, I know I can. And we'll set up a 36-inch plunge, although the plunge rate is not really that big a part of this whole operation. Click next. I'm going to be climb milling, so I want to be running on the right side of the geometry over here, because that's climb milling running along the outside of this thing going this way. I click next. I'll take a side allowance of 3/100ths of an inch because once again I can run a finishing toolpath on this. My overall depth, 3/4 of an inch. I'm going to take multiple steps. We'll go 4 passes at 0.1875. Actually, let's go 3 passes at 1/4 inch. Why not? Live fast, die young. I've cut even depths, 1/4 inch, 3 passes for 3/4 of an inch. Plunge entry, vertical leads are all right. I want round external corners, no internal corners in this toolpath. I'm down to my finishing cut, so I'll select that same tool, 1/4 inch single flute end mill. OK. Tell it the feeds and speeds to use. 32 inches per minute is, that's okay for a finishing pass. Give it a plunge of 32 as well, and finish. Once again, there's the open feature that I'm working on now. Right click on geometry and click reselect. The geometry lights up, so it is the correct stuff. Hit the space bar or right click and hit OK. Then go to profile. In this case it was pocket on these others, but we're doing a profile this time. And click on compute toolpath. And there, once again, is the toolpath. And you can see it's 3 layers of running around the outside of this thing. I'm leaving 3/100 of an inch so that on the finishing toolpaths it bumps inward toward the stock 3/100 and makes one slow pass using the side of the end mill to do all the trimming and cleanup in the finishing toolpaths. So that's everything. We'll go up to milling stock, right click and go to verify, which in version 24 is, in stock version 24 standard at least, is the closest thing we have to simulation. I generally look at an ISO 2. We'll go to zoom and fit it to the zoom window. Run it up about halfway as far as speed goes and start it up. So there's our 1/8 inch end mill running through and drilling out or cutting out the 5/16 bolt holes. If you tell a machinist, by the way, that you're drilling something, that means something very specific to a machinist, and it's an operation that has specific uses and is not what just happened to those bolt holes. That ain't drilling, that's milling. So there the pocket went, and now we're doing the profiling, and so far everything looks just hunky-dory. The finishing tool pass, when it happens, you'll see it's only taking a very small cut. You see a little divot there. And there we go. That's everything that's going to happen on the machine, and we will show that in the next video. Thanks for watching.